All right, stats. So the last two videos of the year cover confidence intervals and significance tests for a mean difference. So we have not really discussed this type of problem before. Um, just a little bit of a nuanced change from the previous two videos to this one. All right, and we'll talk about what it means. All right, so the biggest thing here is this idea of paired data. Okay, so what paired data means is it's a result from recording two values of the same quantitative variable for each individual or for each pair of similar individuals. So this is where in an experiment, you let each person be in the treatment group and you let them be in the uh, control or placebo group, and then you compare the results then. Or you could have a pair of similar individuals. So you could have a husband and wife pair, and you could get the husband's opinion, you can get the wife's opinion, and then compare them directly. All right. So instead of having two different means, you're going to have one mean called the mean difference. All right. So that's kind of the gist, is that you get two sets of measurements, but then you subtract them right away, and that subtraction is the sample value. And those subtractions are the values that you take the mean of, and that's called the mean difference. Those subtractions mean those differences. So you still have to test the two conditions just like if it were a means problem. So random, again, make sure you have random samples, and then or randomized experiment. And then number two, the normal large sample. Again, population is normal. You have a sample size at least 30. And then if those don't count, then your graph of your differences have no strong skewness or outliers. So same stuff as section 9394. But again, you're taking the values and subtracting them first, and then taking the average of those differences. All right, so here's your confidence interval equation right here. So your sample mean difference is the point estimate. You're still adding or subtracting your T star. Again, T star is going to come from the confidence level and the degrees of freedom on your table B. Okay, on your table B. And then this is your standard deviation of the differences, the sample standard deviation of the differences, and then this is the square root of your sample size. Okay. The inference method is called a one sample T interval for a mean difference. So again, that's a one sample T interval for mu diff. And there you go. That's terrible, terrible circle, but there you go. Okay. All right. Okay, and then note there are two ways that an experiment with two treatments can yield paired data. So again, I explained this earlier. So this is the idea of matched pairs again. So either each subject is given both treatments in a random order, or you have pairs of similar subjects and randomly assign each treatment to exactly one member of the pair. Okay, so keep in mind those two options. Okay, so here's example one. Which twin is smarter? The data from a random sample of identical twins are shown in the table, along with a dot plot of the mean difference and the summary statistics. So there's your data. So twin A's IQ being raised in a high income family, twin B's IQ being raised in a low income family. So again, they found these 12 pairs of twins. They must either be adopted, whatever, but one went one way, one went the other way, and we're comparing high and low income. So down below, there's the difference, twin A minus twin B of their IQ. There's your dot plot, there's your summary statistics. Construct and interpret a 95% confidence interval for the true mean difference in IQ score among twins raised in high income and low income households. And we're going to use the 4-step process. I neglected to mention that. Let me do that right here. Now, I was not nice in this section because you're only dealing with a mean difference, not two different means. So you have to start from the beginning. So we need to start with the state. All right. So we are doing a confidence interval. So when we state those, we are trying to estimate. We want to estimate mu diff equals the true mean difference in IQ scores among twins raised in high income and low income households with 95% confidence. We want to estimate mu diff equals the true mean difference in IQ scores among twins raised in high income and low income households with 95% confidence. Okay, so let's go through with the plan. Let me put the plan up here and then I'll erase everything. So when you do a plan, again, this is a one sample. You might say, oh, well, it's two samples. Well, no, it's one group of paired data, right? So it's one sample, t interval for a mean difference, mu diff. Random. Do we meet the random condition? Well, it says random sample of identical twins. So we're good there. So that random condition is met. And now we have to do the normal large sample. Again, your sample size is only 12, so that's not at least 30. There's no mention of normal, so we have to look at the dot plot. And again, if you look at this dot plot, again, I know there's more dots to the right. You might consider these outliers over here. They're not too far apart. So again, this shows no strong skewness or outliers. So the dot plot of, I'm going to finish it up here, of the sample data shows no strong skewness or outliers. So for the normal large sample condition, the dot plot of the sample data shows no strong skewness or outliers. So both conditions are met. So now we can go ahead and do the problems. Let's do it together. Let me erase these things. Okay, so let's do it right up here. So we need to find our sample mean difference right here. So this is X bar diff. So that's our point estimate of 5.833. We need to add our T star. So we need to find T star. So let's go after that. So to find T star, we know our confidence level is 95. We need to get our degrees of freedom. Our degrees of freedom come by taking the sample size, which is 12, and subtracting 1. And that's 11. So there's our degrees of freedom. So now I'm going to go to table B. I'm going to find my T star value using the row 11 and the 95% confidence. So let's go there now. Here's my table B. Let me zoom in. Okay, so row 11, and then I got to find 95%. 95 is this column right here. So I found that, row 11, 2.201. That'll be my t value, 2.201. So I'm back here. So let me start my formula again. So 5.833 plus or minus 2.201. I hope that's correct. Let me just double check. Okay, that is correct. Times your sample standard deviation. So this is X or S diff, 3.927, divided by the square root of your N diff, your 12. Okay, so when I type this in, it's going to be 5.833 plus or minus. I'm going to type all that in to get my margin of error. Let's go do that now. Okay, so I'll open up Desmos graphing calculator. I'll type in 2.201 times a fraction, 3.927 over the square root of 12. And there's my margin of error, sorry. So over here, let's write this down. So it is right now, point estimate 5.833 plus or minus, and I'll go around, that's 3 decimals. So 5, the 1 leaves the 5 the same, so 2.495. And I'll go ahead and add and subtract those. Let's subtract first to get the left-hand number. 5.833 minus 2.495. And 5.833 plus 2.495. And there we go. There's our confidence interval in the mean difference of their IQs. 3.338 to 8.328. Okay, so now let's go ahead and interpret this in our conclusion. We'll go back to our notes here. All right. All right, so for our conclusion, I'll do it down here. Hopefully I'll have a lot of room. Conclude. So remember, there's 2 parts. So first part, we are 95% confident that the interval from 3.338 to 8.3. Give me 1 second. 8.328, sorry. 8.328 captures the true mean difference. And this is where we just kind of restate what we had in the state part. True mean difference in IQ scores, and it's right here, true mean difference right there. In IQ scores among twins raised in high income and low income households. So that's the first part. And then we add a second part talking about what the actual numbers represent in terms of which one's more, which one's less, right? So then we're going to say the interval suggests that the IQ scores, or that IQ scores for twins in high, that's terrible writing, I'm sorry, in high income I think if I actually tried to write nicely, it would take me twice as long to make my videos, so I apologize. So hopefully my talking helps you. In high income households, are between 3.338 and 8.328 points higher than so the IQ scores for twins, then the IQ scores, I'll finish it up here, then the IQ scores for twins in low income households. Okay, so conclusion, we are 95% confident that the interval from 3.338 to 8.328 captures the true mean difference in IQ scores among twins raised in high income and low income households. The interval suggests that IQ scores for twins in high income households are between 3.338 and 8.328 points higher than the IQ scores for twins in low income households. And there you go. All right, so one more video coming talking about the significance tests for a mean difference. All right, almost there.